Hello doctor, my name is Jineshwaran, son of Murthy. My metric number is CE240079. So this is my team member of this group project. They are Muhammad Akimi bin Atan and Muhammad Fakrul Hamdad bin Muhammad Asri. So I want to present about the introduction. So the circuit analysis and simulation are very important in electrical and electronic engineering. As circuit become more complex, doing manual calculation become more time consuming and less practical. So that's why we use MATLAB, which provide powerful tools for both numerical and visual analysis. In this project, we use two main tools, MATLAB GUI, which allow for interactive data input and calculation, and Simulink, which is used to build and simulate the circuit using block diagram. And the circuit we study include the basic component like resistor, voltage source, and current source. And our main objective was to find the nodal voltage V1 to V4 under different condition. At the end, we compare the result from both Simulink and the GUI to see how accurate and reliable each method is and to understand the benefit of the using both tools together.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fakram Jabal Muhammad Asri. My matrix number is DE240066 and I am going to be presenting about the manual calculation for this project. Okay, so the first one is we know that the node at V1 and V3, after we subtract it, we can get the value of the voltage source. So then that will be our first equation, which is V1 minus V3 equals to V. And then for the supernode at V2, we know that we can apply the KCL, which is the current going in into a node, which is equal to the current going out from the node. So we know that I2 will be equals to I3 plus I5. Here is the equation, and then we rearrange the equation into the left hand side, and we get the equation equals to I2 minus I3 minus I5 equals to 0. And then we will be applying Ohm's law, and then we will be substituting the I2 with V1 minus V2 over 6, which is over here, and then minus V2 minus V3 over 8 here, and V2 minus V4 over 10, which is here, will equals to 0. So we can multiply all this equation with 120, and then we will get 20 V1 minus 20 V2 minus 15 V2 minus 15 V3 minus 12 V2 minus 12 V4 equals to 0. And we simplify the equation, we can get 20 V1 minus 47 V2 minus plus 15 V3 plus 12 V4 equals to 0. And that will be our second equation. And then we know that the VA here will be equals to negative V2 plus V3. And over here we write down the equation for VA. It will be equals to negative V2 plus V3. And now we are going to find the voltage at node V4. V4 is here, which means there is only one component, which is the voltage controlled voltage source. So over here we know that it is 2 VA, which means it will be increasing the voltage at VA 2 times. Over here we write down the equation, V4 equals to 2 VA, and from the previous equation, which is VA equals to negative V2 plus V3, we can substitute the VA value into the node 4 equation. So after we substitute the value, we can get the value for V4 equals to negative 2V2 plus 2V3, and we will be rearranging the equation into here. So this is going to be our third equation. So for supernode at V1 and V3, V1 and V3 over here, we use the KCL, which is the current going in will equals to current going out. So this is the current going into the V3. So we got I plus I1 plus I2 minus I3 plus I4 will equals to A. And then so we substitute the value, which is this, the 3M, 3 V1 over V4 plus V1 over minus V3 over 6 minus V2 minus V3 over 8 plus V3 over R5 equals to A. Alright, so rearrange all the equation. We can get 1 over 4 plus 1 over 6 V1 plus negative 1 over 6 minus 1 over 8 V2 plus 1 over 8 plus 1 over R5 V3 will be equals to A minus 3. Then we simplify it and we have this equation over here. And now we have the equation we have 4 equations. We can rearrange all the equation into the matrix form as shown here. Now we have the matrix form. We can actually manually calculate the voltage at every node by varying the value of V1 and the A, and we can vary the value of the voltage source, the current source, and the R5 value. So over here we already calculate 3 cases which have a different value of V, A, and R5. So let's take a look to our first case. So for the first case, we are using voltage equals to 10 volt, our current 15 amp, and the R5 equals to 10 ohms. So we can substitute all the value into the our matrix form, and then we can use the calculator to calculate the matrix. And over here, we'll get the voltage at node V1 equals to 31.6755 volt, at V2 equals to 20.8289 volt, at V3 equals to 21.6755 volt, and at V4 equals to 1.6431 volt.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakim bin Antan, now matrix DE230044. So I will continue to the next part. Is about the simulations of Simulink in Lab 4. So for the first of all, in our Simulink, we use the current source, voltage source, and the resistor, and then we always use the voltage sensor, display, and voltage controlled voltage source. So to find the value, first of all, we must put the value in the voltage source, voltage current source, and then in the R5. So for the first of all, we see to the voltage source. For example, we put the value of voltage source in 5 volt, and then for the current source, we put in the 10 volt, and for the lastly, for the resistor for R5, we'll put in the 5 volt. So after that, we try to the run. And wait a minute. Okay, after we run, this is the value of the Simulink that we get. If we want the same value of our GUI, we must put the value of GUI lah. So for example, for the case 1, I put the value for the case 1 in the GUI. So for the voltage source for the case 1 is 10. Okay. For the R5 is 10 though. This is the case 1 value. So for the last is current. So current we put in 15. So after that, we try to run. Okay, so we get the answer. For the voltage V1, we get 31.68. For the V2, we get 20.83. For the V3, we get 21.68. And for the last is V4, we get 1.693. And the value of the Simulink must same like the GUI. So that's all for the Simulink. I will continue to the GUI. Okay, so I will continue to the GUI simulation or GUI layout for the next after I present the Simulink. So this is the example of GUI, our group GUI layout. So for the first of all, in our GUI we have R5, voltage source, and current source. And for the output we have V1, V2, V3, and V4. And we use the push button for the calculate. And this is the axis one. So for the axis one, we use for the picture of the circuit. So for the first of all, we see the edit text to get the output. The edit text must the same like the coding manual calculation or coding that we analyze in the manual calculation. So we see in the edit text first. Okay, so the tag we setting is edit 2. Edit 2 for voltage source we set in edit 4, and for the current source we set in edit 6. Okay, so it seems like the output. But for the output, we not use the edit text. We use the static text. So the static text is the value we cannot to change in the after we run. So for the first V1, we use text 2, text 3, text 4, and the last is text 5. Okay, so this is our layout. So after we run, we get the coding for our layout. Okay, this is the example of coding after we run our layout. So for the first of all, to get the value same like the Simulink, we must see to the coding analyze manual calculation. So we go to the coding. Okay, so for the first of all, to get the value, we must go through to the push button callback or coding push button. So in the push button, it as calculate in our GUI. Okay, so this is as push button one is as the calculate. So for the first of all, we see to the R. R is R5, V is voltage source, and A is current source. So for the R, we setting in the edit 2. So it seems like the tag that we setting in the text or edit text. So the setting is edit 2. So for the voltage is same, edit 4, and for current is same, edit 6. So after that, we want to get the output, we must see to the V1, V2, V3, and V4 setting. So we see the setup. For the set, we set in text 2. Okay, it seems like the tag that we setting in the static text. So text 2 for the V1, text 3 for the V2, text 4 for the V3, and text 5 for the V4. So after that, to get the value in the GUI, for the first of all, we must run first. Okay. Okay, so after that, we get the layout, our layout for the GUI. Okay, so for the first of all, after we get the GUI layout, okay, we put the value. We want to know the value in the GUI is same or not in our Simulink. So I use the case 1 value. So for the first of all, our case 1 for R5 is 10. For voltage source 10. For the current source is 15. Okay, after that, we start calculate. Okay, this is the value we get, V1, V2, V3, V4. Okay, so let we see to our Simulink. So the value of GUI is same or not. So we run. Okay, so the value of V1 is 31.6755. Okay, so it's same. For the V2, 20.83. Okay, so we see to the 20.8289. So it's same. Okay, so for V3 is 21.6755. Okay, so we see to the 21.68. And for the last is for V4, 1.693. 1.693. Okay, so all the value is same like our Simulink. So that's all for our GUI. So thank you.
So in discussion, the results from the both MATLAB Simulink and the MATLAB GUI were very consistent and accurate across all the test case. Even though the two methods are different, with Simulink using graphical simulation and the GUI using metric computation, the node voltage were closely matched. The small difference we saw were just due to how each platform handle numerical calculation, which is completely normal in digital systems. More importantly, both tools show the correct voltage trend when we change the input value, which means the circuit was modeled correctly. Overall, the GUI made testing faster and easier, while Simulink gave us better visual understanding of how the circuit behaves. By using both tools together, we improve the reliability of our result and gain a better practical understanding of nodal analysis.
For conclusion, the result from the GUI and Simulink were both very consistent with only slight differences caused by the numerical precision. All output responded logically to input changes, confirming the accuracy of the nodal analysis that were done by us in the previous slide. The GUI allowed for quicker testing, while Simulink offered clearer visual representation of the circuit behavior. So, the MATLAB Simulink and the GUI were both effective tools for nodal voltage analysis. The result from each method were nearly identical, with only minor differences attributable to numerical precision. The GUI was faster for rapid testing, while Simulink offered a clearer and visual understanding of the circuit behavior. Together, these tools complement each other and improve learning and accuracy in electrical circuit analysis. Thank you.